We're going to start Unit 3. We're going to talk about the confidence intervals. Introduction. The Pew Research Center conducts phone surveys to gather opinions of adults in the United States on a variety of political issues. In a February 2017 Pew Research Center survey, researchers asked a random sample of US adults if they approved of the job Donald Trump is doing as president. Well, the information, the data that we have is that 39% of the respondents indicated that they approved of President Trump's job performance. For the purpose of this problem, we can assume that the margin of error for this survey was plus minus 2.5%. So what's the meaning of that? We ran a survey. The information, the data that we collected is 39%. Remember that as a statistician, when you collect data, there are always some error involved. In this question, the margin of error is given to us as 2.5% plus minus. Later on, you see why we need plus and minus sign when we are talking about the margin of error. Try this. Discuss the following questions. A, is the 39% a parameter or is it a statistic? Well, what is a parameter? What is a statistic? When we're talking about parameter, we're talking about numerical characteristics for population. So let's write this down here. Parameter is related to population. When you're talking about a statistic, you're talking about numerical characteristic for a sample. So statistic, sample. So let us think about this question. This question says, hey, we didn't gather information from population. We had a survey. When we are talking about surveys, it means that we are talking about samples. Survey. So when you see the keyword like survey, it means that you're dealing with a sample. It means that you are collecting numerical characteristic about the sample or statistic. So it is statistic. The reason behind it, because it summarizes the result of a sample. It is a statistic, and this statistic says, hey, the proportion is 39%, since it summarizes the results of the sample. Where did sample come from? Sample come from a survey, not the whole population. So I expect you to ask, well, how do I know it's not a population? First of all, it's a survey. And remember that when you're talking about population, it means that you're dealing with census. Part B, it says, well, do you think the population proportion of adults in the US who approved of President Trump's job performance in February 2017 was exactly 39%? Is the population proportion is exactly 39%? Remember that we collected a data by running a survey from a sample, not everyone in the United States. It's just a sample. So this proportion, this sample proportion, which is 39%, is not the representative of population. So the sample proportion is 39%, which is not a representative of the population proportion. To get the exact information about population proportion, we need a census. We need to ask everyone in the United States about the performance of the job. So this 39% is the sample proportion, not the population proportion. So now I expect you to ask, well, I know this is not population proportion, but it's representing something. You might say, hey, I know margin of error is 2.5%. So we can say the population proportion is not one exact number, but based on our sample proportion and the margin of error, we can say that, hey, the population proportion is in between 39% minus 2.5% and 39% plus 2.5%. The population proportion is in between these two numbers, 39% minus 2.5% and using a comma, 39% plus 2.5%. This is actually your confidence interval. The confidence interval, CI is equal to. So we use parentheses and we put a comma in between 39% minus 2.5, which is 36.5%, and 39% plus 2.5 is 41.5%. What's the meaning of that? It means that the population proportion is a number in between 36.5% to 41.5%. This is called the confidence interval. So to construct your confidence interval for proportion, you need a sample proportion, which in this case is 39%, and you need the margin of error, which is 2.5. Sample proportion minus margin of error, sample proportion, plus margin of error. Very well. Let us move on to the next page. Now we're going to officially represent everything in its mathematical form, mathematical notation. The sample proportion is denoted by P, and we put a hat on top of it. So sample proportion, or P hat. It has a hat on top of it. P hat is a single estimate of population proportion. So sample proportion is denoted by P hat. Population proportion is just denoted by P. So this sample proportion, which is a single estimate of population proportion, has a name. We call it a point estimate. Point estimate. Point estimate for population proportion is sample proportion, or P hat. Well, an interval estimate is a range of values used to estimate a population proportion. These interval estimates are centered at a point estimate. The interval is formed as point estimate plus minus margin of error, or as you saw, the interval point estimate minus the margin of error, comma, the point estimate plus margin of error, ME, or margin of error. So like previous example, we had 39% minus 2.5% and 39% plus 2.5%. This is your confidence interval. Using the information about the pool above, fill in the following tables. Identify the point estimate and margin of error. In previous example, the information given to us, P hat is 39% or 0.39, and the margin of error, E, is given to us as 2.5%, 39%, and 2.5%. Lower limit, point estimate, minus the margin of error, or P hat, minus the margin of error. This is what we calculated. 39% minus 2.5% and 39% plus 2.5%. We calculate these two. These are equal to 36.5% or 365. And then we calculate the next one as 41.5%. So the interval, the confidence interval that we calculated, again, this is 0.365 and 0.415, or 36.5%, comma, 41.5%. This is what calculated in previous page. Just writing everything nicely in a table. Question 3 says, well, now suppose a politician had stated that the true population proportion population proportion. Guys, remember that this is denoted by P and the sample proportion P hat. True population proportion of adults in the US who approved of President Trump's job performance in February 2017 was as high as 50%. Would her statement be supported by these statistics? Again, remember that you had a survey. In that survey, you had P hat 39% with margin of error 2.5%. You found a confidence interval that say, hey, the population proportion is going to be in between 36.5% up to 41.5%, not smaller than 36.5%, nor larger than 41.5%. But you are watching TV and you see this news that a politician stated that population proportion is as high as 50%. You're the statistician. You have the actual data. The data says, hey, the population proportion is in between these two percentages. So you quickly say, this news is not true based on the confidence interval, the population proportion is not larger than 41.5%. So it cannot be 50%. It cannot be 50%. Well, suppose another politician stated that the true population proportion of adults in the US who approved of President Trump's job performance in February 2017 was as low as 37%. Would her statement be supported by these statistics? They might not say, hey, it's as high as 41% or 41.5%. They're just saying that, hey, let us just take a look at the proportions in the lower bound. It's as low as 37%. Is this true? Of course. The lower bound is 36.5%, and 37% is larger than 36.5%, which is a number in between these two percentages. So as a statistician, you collected the data, you formed and constructed your confidence interval, and you already know that the lowest proportion is 36.5%. So if somebody says, hey, it's in the lower bound of 37%, you say yes, that's correct, because I see this number here in this interval. So the answer is yes, 37% is contained in the confidence interval. Confidence interval. Very well. More definitions. Confidence intervals for the population proportion. We call the interval estimate for a population parameter a confidence interval. To construct a confidence interval, we need two things. First, we need a point estimate. And note that since we are dealing with proportion, that point estimate p hat is in the form of decimal or percentage. We also need a margin of error. The margin of error is subtracted from and added to the statistic to find the endpoints or lower limit, upper limit of the confidence interval. A simple formula for the confidence interval is point estimate plus minus margin of error, or confidence interval is p hat minus margin of error, p hat plus margin of error. Your p hat is the sample proportion or your point estimate, which is in decimal or percentage form. Point estimates such as sample proportions, and later on we're going to use sample means, are easy to compute. We have already practiced computing sample proportions. To compute a margin of error, E, we have to think about the sampling distribution of all sample proportions from a given sample size. We have a formula to calculate the margin of error. Later on, we're going to see how to calculate the margin of error. Okay. To learn about margin of errors, let us think about some sampling distributions, like sampling distribution for sample proportions of M and M's. In this experiment, the sample proportion of N and M's are calculated. The mean or mu sub p hat is 24%. This is just one example to help you find the margin of error. P, 24%. To find the margin of error, we need something that we call the standard error. The standard error follows the formula sigma sub p hat. To find the standard error, we need the square root of p times 1 minus p divided by n. Suppose in this experiment, your n is 50, the sample size. Since p is 24%, 0.24, the standard error, sigma sub p hat, standard error, sigma sub p hat is equal to square root of p, which is 0.24 or 24%, times 1 minus p, 1 minus 20.24 or 24%, divided by n, which is 50. So the standard error in this experiment is almost 0.060. So To find margin of error, first, we need to find the standard error. The standard error has formula. First of all, it's denoted by sigma sub p hat, which is equal to square root of p times 1 minus p divided by n. We find standard error, SE. In this experiment, it is just 0.060. Then the margin of error, E, is equal to. So if the question says, well, we need a confidence interval like 95%, going to be 95% confident about our result, then you're going to multiply 1.96 by your standard error, sigma sub p hat. It gives you the margin of error. 95% confidence interval, the margin of error is 1.96 times this number that you calculated here. So E, or margin of error, is 1.96 times 0.060. Let's calculate this number here. Okay. 1.96 times 0.060, which is 0.1176, or just, you can say that it is 0.18. So the margin of error is approximately 0.18. This is our margin of error for this experiment.